Hey everybody, it's John Broadwell, creator of the Serial Wombat open source project, and specifically the Serial Wombat 8B Kickstarter that's coming up. It's a smart I/O expander, 8 pins. It can do analog to digital conversion, PWM, servo, I2C to UART, matrix keypad, quadrature encoders, H-bridge control, all kinds of great stuff, all from I2C, and it's backed up by Arduino, MicroPython, and C# libraries to make it easy to use. So I'm just about at the finish line, I think, for the hardware design. And what I'm asking from you guys is to be my design review crew. Tell me about this board, see if you think I missed anything or if there's something you think I should do differently. Because this probably is going to be the 5th iteration of this board and likely the one that'll go into production for the Kickstarter. So let's start with the schematic. As you may know, we're using the CH32V003 microcontroller. It's a 20-pin flat pack package. And out of that, we're going to draw 8 Serial Wombat pins plus the I2C, SDA, and SCL lines. So let's just walk around, starting with pin 1. The Serial Wombat pins are all on port D, and I need them to all be on port D because of the DMA scheme that I use for a lot of the streamed bit and input and output. So all 8 of those pins have to be on pin D. Unfortunately, not all of pin Ds have analogs. So in some cases, you'll see I've attached one of the pins that has an analog to one of the other port D pins. And in that case, when you're doing digital implementations, I'll be using port D. When you want analog, I will turn off port D and use the A to D converter on port A. So Wombat pin 6 is going to be on pins 1 and 2, port 7. Wombat pin 7 is on pin A2 and pin D0. Again, that's the digital here, the analog here. Pin 4 is a ground. That's straightforward. Pin 6 is voltage, and we have a 100 nanofarad bypass capacitor to ground. The Serial Wombat firmware will look at the state of 4 solder jumpers, A0, A1, A2, and A3, and those will be used to determine the I2C address. So the first of those goes into port PC0 on pin 7. These have weak internal pull-ups that will turn on long enough to take a look at to see if any of these solder jumpers are grounded, and then we'll turn them back off. SDA is limited to be on pin number 8. SCL has to be on pin number 9. This chip does not have a peripheral pin selector or whatever that lets you randomly reassign peripherals. There will be a pin PC3 that if you ground this, it will force it to stay in the bootloader. That way, if you download some code of your own that hangs up the chip and you can't send the jump to boot command, there's still a path to get back into bootloader and download new code. Wombat pin 0 is on PC4 for analog and PD1 for digital. This pin is also the software I/O debugger pin, and by default it comes up as an input and is floating. And if for some reason noise or a signal would be introduced on this pin that looks like what comes out of the debugger, it can actually throw the chip into debug mode. So on this particular pin, we have a 100K pull down that will prevent any noise from going in on the pin. There'll be a note in the user guide warning people that Wombat pin 0 has to not have an input signal that looks like the debugger. That's unlikely, but it could potentially be a problem. The nice thing about this is that you can hook up the debugger at any time and kick the thing into debug mode, and that if you want to, you'll be able to use this SW8B board kind of as a general purpose CH32V003 dev board. We've got 3 more address pins on A1, A2, and A3. That makes a total of 4, so you'll be able to pick from 16 I2C addresses. One of the cool things about that is that it will let you daisy chain up to 16 boards, as I've done right here. And I actually have that working, I can address all 16 boards, giving you a massive 96 I/O pins that could be spread throughout a project. I don't know that a lot of people do that, but it's fun to think about. Wombat pins 1, 2, 3, 4, and 5 are very straightforward on pins PD2 to 6. There are optional I2C pull-up resistors, and those go through another solder jumper. If you look at this one on the back, you solder bridge all 3 of these pins together, and it provides 2K2 pull-ups on the I2C. These particular, and I guess let's go back and finish up the schematic. Other than that, we have the pin out here. We're going to use ground, which will go to both sides. That'll allow you to daisy chain the pins together like we did before. VDD goes to both sides. SCL goes to both sides. SDA goes to both sides. Then you have your Wombat pins 0 through 3 and then 4 through 7 on opposite sides of the board. I'm going to have some other boards available that lay these out a little bit different for some special applications. But this is, when people say a Serial Wombat 8B board without any other qualification, this board will be what we're talking about. So we can see the layout here. I rotated the chip by 45 degrees to ease the layout. The boot jumper is right here next to the boot pin. Here's our 100K pull down on the debugger / Wombat 0 pin. A 100 nanofarad capacitor, which looks like it's actually far away, but it's actually quite close to the chip in real terms. It's a 1/10 of an inch from here to here. And then the 2K2 pull-up resistors, which are controlled by this optional solder bridge. And actually, I got to get rid of this SJ1. I don't want it to show there. But that'll be gone on the silk screen. Other than that, this is the labeling on the silk screen. It shows you what the default I2C address is, plus either 8, 4, 2, or 1, some combination of these solder jumpers. It's board PCB 0023 version 5, so I've got my version identifier on it. And if you go to serialwom.com/P29, that will get you the documentation on this particular board. I put a little notch up here on the silk screen to help you orient the board, and it is a Serial Wombat 8B board. So that's pretty much the size of it. Any comments that you've got, I'd appreciate it. I'm really excited about this project. Hop on over to the Kickstarter and sign up to follow so that you can be some of the first people to get this incredibly cool small board. Goal on these is to have this under $1.50 in small packs and even cheaper in bigger packs. And so it should be the one I2C expander that everybody wants to have in their toolbox. That's what I'm going for. So please leave me some comments. Tell me if you think I'm on the right track. Tell me about any changes you might make or variations on this board that you'd like to see. One that I'm thinking about is with screw terminals on the side for those of you who have loose wires you want to deal with. Another one will have all 8 I/O pins lined up on one side so that you can do a backpack on a matrix keypad or something like that where they're all lined up. Another one will be designed for user input. And then we have seen in previous videos the boards that are designed specifically with servo connectors and current feedback control. And I've got another one that's designed with an H-bridge and encoder pins built in automatically. So excited about those as well. All those will be available as Kickstarter rewards. So hop on over there, check it out, give me some comments, let me know what's going on. And until we talk again, have fun and keep making stuff.